tangent lines and rates of change. The slope of the graph of f at x equals c means the slope of the tangent line to the graph at x equals c. If y equals a function of x, at a point on this function where x is equal to c, a tangent line can be drawn to the function, and the slope of this tangent line is also called the slope of the graph of the function at x equals c. Please write these three definitions. The symbol m with a t subscript, a bar, and another subscript x equals c is read: the slope of the tangent line at x equals c equals the limit as x approaches c of f of x minus f of c over x minus c. An alternate definition, another definition of the slope of the graph of f is this one. I'll circle in purple. The slope of the tangent line at x equals c equals the limit as h approaches 0 of f of c plus h minus f of c over h. And this third one is the same as the one in purple, except the c's are replaced with x's. This c and this c and this c are replaced with x. We'll say the slope of the tangent line at x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Notice the first limit has x approaching c, the other two have h approaching 0. Pause the video to get all of these written down. Here's an example. Find an equation of the tangent line to f of x equals x squared plus 3x plus 7 at x equals negative 2. There's basically 3 steps to get this answer. First, we find y when x equals negative 2, which means find f of negative 2. F of negative 2 is going to equal negative 2 squared plus 3 times negative 2 plus 7, which is equal to 5. Then we find the slope of the tangent line to the function at x equals negative 2 using one of the definitions from the previous slide. The slope of the tangent line equals the limit as h approaches 0 of f of x plus h minus f of x over h. Specifically, the slope of the tangent line at x equals negative 2 is this definition with each x replaced with negative 2. Here and here. The limit as h approaches 0 of f of negative 2 plus h minus f of negative 2 all over h. F of negative 2 plus h is going to be this function with negative 2 plus h in place of x. Instead of x squared, it's negative 2 plus h squared. Instead of 3 times x, it's 3 times negative 2 plus h. But the plus 7 is still there. And then this blue, f of negative 2, is what we figured out in step 1. F of negative 2 is 5. Then we do some algebra. Negative 2 plus h squared is this trinomial, 4 minus 4h plus h squared. Distribute this 3, and we get negative 6 plus 3h. Plus 7 minus 5, I just copied that. Also copied the over h. Then combine like terms. 4 minus 6 plus 7 minus 5 is 0. And negative 4h and positive 3h is negative 1h. And don't forget the term that has h squared. So after combining like terms, all of this red and blue turns into h squared minus h. We still have over h. The limit of h squared minus h over h equals the limit of h times h minus 1 over h as h approaches 0. Then this h and this h cancel. H divided by h is 1. Now we have the limit of h minus 1 as h approaches 0. We find the limit of h minus 1 as h approaches 0 by replacing h with 0. And there's the result. Negative 1 is the slope of the tangent line at x equals negative 2. And all we do is to find the equation of the tangent line, we need to know that the equation of a line is y minus y1 equals m parentheses x minus x1. The y1 is 5. We got that in step 1. The m is negative 1. We just got that in step 2. And the x1 is the x that was given in the question. And then this simplifies to y equals 3 minus x. Y equals 3 minus x is the tangent line to this parabola at x equals negative 2. Make sure you have all of this written down. And this is what it looks like. F of x equals x squared plus 3x plus 7 is this blue parabola. This red line is what we just found. Y equals 3 minus x. It's a red line that is touching the parabola at the point where x equals negative 2. The line is touching the parabola. That means the line is tangent to the parabola at x equals negative 2. Another way to find the slope is to use one of the other definitions. The slope of the tangent line is equal to the limit as x approaches c. In the last method, we've had h approaching 0. And it's f of x minus f of c over x minus c. The function in this example is this red, x squared plus 3x plus 7. And f of negative 2 is what we found way back here. F of negative 2 is equal to 5. This red f of x is just the given function. And when we have x squared plus 3x plus 7 minus 5, combine like terms and get x squared plus 3x plus 2, which can be factored to x plus 2 times x plus 1. And since that's over x plus 2, we have the limit of x plus 1 as x approaches negative 2, and we evaluate the limit by replacing x with negative 2. And we get negative 1 to be the slope of the tangent line at x equals negative 2. So the point is we could use either one of the definitions for the slope of the tangent line. Make sure all of this is written down. The average velocity of a body moving along a line from time t equals a to time t equals a plus h is equal to the change in distance divided by the change in time, symbolized delta s over delta t. You're going to use s to represent the distance that the body has moved. And the change in distance means subtract two distances. The change in time means we subtract 2 times, actually these 2 times, a plus h minus a. A plus h minus a is equal to h. Example, the position of a point moving along a line is s of t equals 5t to the third minus 2t squared plus 8. Find the average velocity of the point in this time interval. That means from t time equals 1, maybe that's 1 second, to this time, 1.4 seconds. And we just learned this formula to answer. The average velocity is s of a plus h. A is the 1. H is the change in time. So in this case, the change in time is 1.4 minus 1, which is 0.4. So the average velocity is s of a plus h minus s of a all over h. So like I said, a is 1. H means the change in time, which is 0.4. A is here again, which is 1. And h is the change in time. S of 1.4 means replace all the t's here with 1.4. It'll be 5 times 1.4 to the third minus 2 times 1.4 to the second plus 8. That's all in red. S of 1 means replace all the t's with 1. 5 times 1 to the third minus 2 times 1 to the second plus 8. And all of that is in blue. So it's the position of the point at time 1.4 minus the position at time equal to 1. And this right here is just the change in time. From 1 to 1.4, the change is 0.4. This calculates to equal 17. That number 17 would be the average velocity over this time interval, 1 to 1.4. The instantaneous velocity is the limit of the average velocity as h approaches 0. We make the h, which is the change in time, get closer and closer and closer to 0. The instantaneous velocity is the same as the average velocity, but with this in front, limit h approaches 0. That'll be the velocity at the instant, at the exact time that t is equal to a. An example is a sandbag is dropped from a balloon 480 feet above the ground. The distance s of t from the ground to the sandbag after t seconds is given by s of t equals negative 16t squared plus 480. Find the velocity of the sandbag at these 3 times. Part A at t equals a seconds, B is at t equals 3 seconds, and part C, find the velocity of the sandbag at the instant it strikes the ground. Try to do this problem on your own and see if you can come up with these correct answers. And then we will do these problems in class.